far beyond the reach of any galaxy, deep in a darkness so complete it swallows even imagination. A single faint glow lingers. It is not vibrant, not proud like the stars that once filled the cosmos. It is weak, barely holding on. The last star. A dying ember, stretched thin across eternity, burning the final remnants of fuel it has guarded for trillions upon trillions of years. For ages beyond comprehension, it has endured. While galaxies dissolved and the great stellar cities of the universe faded into silence, this one stubborn light persisted. But even endurance has limits. Slowly, almost imperceptibly, its glow dims. The processes that once powered its brilliance now sputter. Energy leaks away into the void. And then, without ceremony, without witness, it fades. With that final flicker, the universe crosses a threshold. The great cosmic performance, billions of years of light, structure, chaos, and creation, comes to a close. No applause, no audience, just silence. What remains is not life, nor motion, nor warmth. Only relics. Black dwarfs drift cold and invisible, the frozen corpses of once luminous stars. Neutron stars spin quietly, their violent births long forgotten. And scattered among them, like ancient monuments to gravity itself, black holes persist, massive, patient, and nearly eternal. These are the fossils of a younger universe, echoes of a time when light mattered. But even these titans are not forever. Given enough time, timescales so vast they make trillions of years seem like moments. Black holes themselves begin to evaporate. Through a slow quantum process, they leak energy, shrinking over unimaginable durations until they too vanish. One by one, the last anchors of structure dissolve into nothingness. Eventually, the universe becomes something entirely unfamiliar. A place with no stars, no galaxies, no recognizable forms of matter. Just an immense cold expanse, empty, at least at first glance. But emptiness in physics is rarely truly empty. Even in the darkest void, something remains. Quantum fields, subtle, restless, ever-present, continue to fluctuate. They ripple softly across space-time, even when there is nothing else left to disturb them. And if time continues without end, if the universe truly has an infinite future, then these tiny fluctuations take on extraordinary importance. Because in an infinite amount of time, even the rarest events are not just possible, they are inevitable. Given enough time, random fluctuations can briefly create pockets of order. A single particle appearing from nowhere, a cluster of atoms assembling momentarily before dissolving again, a faint structure in the void, forming purely by chance. These events are extraordinarily unlikely, but infinity does not care about unlikely. It guarantees outcomes. And if small structures can arise, then larger ones can too. Follow that logic far enough, and it leads somewhere deeply unsettling, because there is nothing in the laws of physics that forbids a momentary spark of awareness from forming spontaneously. Not born from evolution, not shaped by biology, but assembled purely by chance. A mind, flickering into existence for a fraction of a second, complete with thoughts, memories, and a sense of self, before disappearing again into nothingness. In an eternal universe, such occurrences may vastly outnumber the structured, meaningful histories we associate with life. The story we tell ourselves, the one involving stars, planets, biology, and civilization, may not be typical at all. It may be the rare exception. And that realization forces a troubling question. What gives our experience meaning? Part of the answer lies in endings. Endings define stories. They give shape to events. They allow consequences to matter. Without an end, narratives unravel. Significance dissolves into repetition or randomness. And the universe, if truly infinite in time, risks becoming a place where meaning itself becomes unstable. To understand why, we need to step back, not into the distant future, but into something more familiar. Time. For centuries, humans have tried to measure it, control it, and understand it. One of the most beautiful examples of this effort stands in the heart of an old European city, a medieval astronomical clock. Every hour, figures emerge, bells ring, and intricate mechanisms move in perfect rhythm. The sun and moon are tracked across the sky. Seasons are mapped. Days are counted. It is a machine built not just to tell time, but to represent the cosmos itself. For over 600 years, such clocks have endured war, disaster, and change. Through it all, they continue ticking, insisting that time flows steadily, predictably, from one moment to the next. But what exactly are they measuring? What is time? And more importantly, does it have an end? Modern cosmology offers one answer. Time began. Roughly 13.8 billion years ago, the universe burst into existence in an event we call the Big Bang. Space and time themselves emerged in that moment. There was no before. Time did not stretch infinitely into the past. It had a beginning. But what about the future? Will time stretch forward forever? Or will it, too, come to an end? The answer depends on the fate of the universe. For much of the 20th century, scientists considered the possibility that the universe might eventually collapse. Gravity, pulling everything inward, could reverse the expansion and cause a big crunch, ending time in a final singularity. But observations changed that picture dramatically. In the late 1990s, astronomers discovered that the expansion of the universe is not slowing down, it's accelerating. Galaxies are being pushed apart faster and faster by something we now call dark energy. We still don't fully understand what dark energy is, but its effects are clear. It acts like a kind of anti-gravity, stretching space itself. If this acceleration continues, several futures are possible. One of the most extreme is known as the Big Rip. In this scenario, expansion becomes so powerful that it eventually tears apart everything. Galaxies are ripped into pieces. Stars are torn from their systems. Planets disintegrate. Eventually, even atoms are pulled apart. And at the very end, space-time itself breaks down. Time does not just continue, it stops. There is no after, but this outcome is uncertain. A more likely scenario is something called heat death. In this future, the universe continues expanding forever, but more gently. Matter spreads out. Energy becomes evenly distributed. Differences disappear. There are no gradients, no flows, no processes. Everything reaches equilibrium. Nothing happens anymore. Time continues, but it becomes meaningless because change has ceased. And yet, even in this frozen state, quantum fluctuations remain. Tiny, random events continue indefinitely, which brings us back to the strange possibility we began with: spontaneous order in a sea of chaos. To understand why this matters, we need to consider a key concept in physics: entropy. Entropy is often described as a measure of disorder. Systems naturally evolve toward higher entropy, toward more disordered states. This tendency gives time its direction. We remember the past, not the future, because entropy increases. But here's the catch. The laws of physics themselves don't require entropy to increase. They allow it to decrease. It's just incredibly unlikely. In an infinite universe, however, even the unlikely becomes inevitable. Given enough time, entropy will occasionally decrease. Systems will spontaneously become more ordered. Entire configurations of matter, perhaps even entire histories, could reappear. This leads to a concept known as recurrence. In a finite system with infinite time, every possible arrangement of matter will occur again and again. That means somewhere in the vast future, atoms could rearrange themselves into an exact copy of you, with your memories, your thoughts, your experiences, not once, but infinitely many times. It's a strange kind of immortality, not continuous existence, but endless repetition. And it raises profound philosophical questions. If your life repeats exactly, do your choices matter? Is anything truly unique? Can meaning exist in a loop? For some, this idea is deeply unsettling. For others, it's even worse, because not all repetitions would be meaningful lives. Some would be brief, random fluctuations, like the so-called Boltzmann brains. These hypothetical entities are self-aware minds that form spontaneously out of chaos, complete with false memories and perceptions. In an infinite universe, Boltzmann brains could vastly outnumber real observers, which leads to a disturbing possibility. Statistically, it might be more likely that you are one of these fleeting fluctuations than a being with a genuine history. That your memories, your world, your entire experience could be a momentary illusion. It's an idea that challenges the very foundation of reality. And yet, it emerges naturally from the physics of an eternal universe, unless time has an end. Endings, it turns out, may be essential, not just for stories, but for meaning itself. A finite universe avoids many of these paradoxes. It limits repetition. It constrains randomness. It preserves the significance of events. But whether time truly ends remains an open question. Some theories suggest something even more radical, that time doesn't fundamentally exist at all. In certain interpretations of physics, the universe is not something that unfolds moment by moment. Instead, all moments, past, present, and future, exist simultaneously, like points on a map. This is known as the block universe. In this view, time does not flow. There is no movement present. Every event simply exists, fixed within a four-dimensional structure. The feeling of time passing is an illusion, an emergent property of consciousness moving along a particular path. Other theories go even further, suggesting that time emerges from deeper, timeless laws, that at the most fundamental level, reality simply is without before or after. If that's true, then asking whether time ends may be like asking where a circle begins. It's not the right question. And yet, from our perspective, inside the universe, experiencing it moment by moment, the question feels unavoidable. Because we live in time, we remember the past, we anticipate the future, we experience change, and for us, the future remains uncertain. Will the universe end in a final, dramatic event? Will it fade into eternal stillness? Will it loop, repeat, or dissolve into randomness? Or is time itself just a story we tell, a way of making sense of something far more complex? We don't yet know. For now, there is only this moment. A brief window of awareness in a vast and mysterious cosmos. Whether it is part of a grand narrative, a fleeting fluctuation, or a fixed point in a timeless structure, remains one of the deepest questions we can ask, and perhaps one of the most important. Because whatever the true nature of time may be, our experience of it is real, and within that experience, meaning is something we create, not from infinity, but from the finite moments we have.